AI happens pretty fast. If you don't stop and look around once in a while, it might just pass you by.
Hello, and welcome to The Reasoning Show. I'm your host, Brian Gracely, and today I have reason to believe that while many of you are excited about what's going on in the AI agent space around Agentic AI and all the interesting things that you're going to be able to start doing, whether it's at work or to help your business, that maybe you aren't thinking enough about, some of the challenges that might arise as you start to bring agents into your workplace, into workflows that you're trying to help the business with, and things that you may not exactly be sure what's going to happen. So today we're going to dig into a new framework, a new project, a new open source project that I think will be very relevant to many of you, especially those of you that use Kubernetes within your day-to-day work. With your organizations are using Kubernetes to help deploy containers today, but also, every agent is essentially software running in a container on a Linux process. And so many of the same sort of principles are going to apply. So today we're going to dive into that right after the break. Today's show is brought to you by Vention. AI promises speed, but for many teams, it means more meetings, more tools, more confusion, and still not much to show at launch. Vention works differently. AI is embedded in their processes from the first architecture decision through deployment. Their engineers use AI to cut repetitive work and focus on what matters most, building the right product faster. This is their peace of mind promise. You get clear ownership, full visibility into progress, and delivery that you can rely on. Ready for an expert developer who actually delivers? Visit ventionteams.com. And we're back, and today excited to have Morgan Foster, who is both co-chair of the Kubernetes AI Gateway Working Group, as well as maintainer on a new project called Kagenti, which is very exciting, especially as we all seem to be talking about AI agents these days, and we're looking for ways to bring those into our businesses and help them do productive stuff. So Morgan, welcome to the show. Great to have you on. Before we dive into this, give us a little bit about your background, because you have worked on at a number of very interesting places and also a number of very interesting projects. So give us a little bit about your background before we dive into Kagenti and all things sort of frameworks around Agentic.
Absolutely. Thank you for having me on. I felt really happy to be invited to chat about agents and generative AI. My background is pretty widely varied. I studied physics in school, and like a physics major who wanted to have a career without getting a PhD, I got pulled into software engineering. I worked at Mozilla and had a great time there. I got the chance to work on SpiderMonkey, which is the JavaScript engine there that Firefox uses, and I had a lot of fun implementing back in the day ECMA 6 features. If you recall those, that was a real watershed moment in the JavaScript community. But from there, I moved on to Google. At Google, I was a site reliability engineer. I worked on Google's CDN that's used for YouTube videos primarily. So worked on the Google payment stack. And ironically, a lot of what I did there was static analysis. I sort of had the idea that, and it's a true idea, that I could use static analysis to improve the reliability of our code. So I did some stuff like I auto-instrumented the payment stack, so that it would be easier to disambiguate between errors coming from payment processors external to Google and errors coming from within the payment stack itself, that sort of thing. But then from there, I went on to Box and Twitter, where I was also a site reliability engineer, and I was focusing on solving data center scale issues. So I worked on trying to improve the efficiency of rollouts to software to data centers, which is where a lot of outages were happening in any company that has their own data centers. If you look at their outages, it's almost always some sort of change to something like Puppet.
Yeah.
And so we were trying to make that process a little nicer. And so from there, I took a little break after Twitter and sort of had a chance, fortunately, right in 2023 to look at the software industry and how it was changing with generative AI. And I started a company of my own, just a small firm where I was assembling data sets for nonprofits. This is before there were agent frameworks like we have today. LangChain existed early on, but everything was pretty primitive, which played to my advantage. It's Pydantic. And I had this idea where I could build models in Pydantic and dump their schema, and it's just text. And sure enough, OpenAI's models at the time, as less performant as they were than our models today, you could feed them those schemas and they could return you a model that could be serialized back into a Pydantic object. And so I used that premise to build a web crawler, essentially, that was able to find really difficult to grab documents from like school board websites where they're just hidden in the most ridiculous places. And then I built a pipeline because sometimes these documents are like photos of like paper notes from meetings. And so had a nice OCR pipeline and built some really nice data sets that nonprofits were using to try to like save music programs and things like that. And then from there, I saw an opening in emerging technologies at Red Hat. And I was thinking that it was time to get back into the world of distributed systems instead of the world of helping nonprofits, as much as I love helping nonprofits. And it looked perfect because I get to work with IBM research folks. I get to work with stuff that is, as the name implies, emerging. So I'm constantly getting to think about the future and play with the newest stuff, which makes me really happy. And so that led me to where I am today, which is trying to help define what generative AI first networking is going to look like in Kubernetes via Gateway API, and also how we can extend the platform primitives we offer on Kubernetes to help support fleets of agents.
No, and I thought, especially the work that you've been doing recently, like you said, around networking and now around agent frameworks was really relevant. Especially as we think about how companies are going to start bringing this into their enterprise and mid-size environments where, kind of YOLOing things or just putting a Mac Mini on your desk or something like that really isn't going to be acceptable. So I'm excited to kind of dig into, how you've been thinking about this space. Obviously, you sort of thrive, it seems like, in the space that's sort of between systems, trying to figure out how to make them reliable, make them scalable. So why don't we start with this project Kagenti? It looks a little bit like K-Agent, if you will. What is it? What was the inception of it? And what's drawn you to wanting to kind of explore this space?
Absolutely. So Kagenti itself is the not very fun elevator pitch for nerds would be, it is an agent framework neutral middleware on Kubernetes. Unpacking that is the fun part. So how I arrived to Kagenti, it was a project that started in IBM research. And we have a sister team that we work with really closely in emerging technologies. We have a few sister teams actually in IBM research. And one of these teams was just thinking about what is it going to look like to build secure multi-agent systems. And so they started working on a research project, essentially, where they were building these sort of primitives that they thought might be useful. Independently of that, we were exploring how we could build products to support real-world use cases today, to support enterprises that are trying to deploy agents. And we were looking at the way folks were struggling. And folks are struggling because your developers are all working with this model where they have a coding harness, an agent running on their own laptop. They're in the loop and they're saying, okay, yes, no, whatever. Of course, now we have larger orchestration systems evolving, but we'll stick to that and we'll say everything's being developed with the model of running on my own laptop. But now we're trying to throw this over a wall and make something useful that a person who isn't going to want to open a terminal on their laptop can use at your company. And so we were looking at those struggles, and a lot of what was happening was folks were like, which framework should we use? Should we use Crew AI? Should we use LangGraph? Should we use Llama Stack? And immediately I saw that this was the wrong question, in my opinion.
Yeah.
There was a lot of work being done to compare all the frameworks, and they do things differently, absolutely. But where we could add value were the things that they were all trying to do in slightly different ways.
Yep.
And the way we add value is we say, this is something that's common across all these frameworks. We should move that to the platform level. And then we can solve this problem robustly at a layer below the agent workload. And then that makes life easier for people. We can run an agent in any framework and then already know that we can secure it, that we can find it, that we can do all these things that we can talk about Kagenti doing. So I built a prototype. of my own, which was essentially this. It was a resource for representing agents, and it would also keep track if your agent spoke A2A of an agent card that specification calls for. And I started using that resource and a controller I made to sort of start playing around with this. And through that, I found Kagenti, and they were doing the same thing, but they had a team of researchers working on it. And so I had done some stuff a little different from them, and we merged our projects together, and it became what Kagenti is today, which is essentially the discovery features of what I was working on, where I was looking at the A2A protocol and saying, this is a really cool protocol, not just for describing the way agents can talk to each other, but for its discovery primitives. And what they were doing, which was all about workload identity and using that identity to federate with existing identity providers and access management systems.
Yeah, I mean, if you think about, agents as being, applications or pieces of software, I would suspect that there's going to be a lot of common things. Like you said, they may not all be exactly the same, but a lot of commonality in terms of, what sort of identity does it have? What protocols should it speak or not speak? How should it be allowed to access data? How do you trace it or track what it's doing? And, things that we have to do either with sort of end users or with applications. Walk me through a little bit about what you've learned about maybe what agents do differently from sort of a traditional application. And then what are some of the things that you're trying to build Kagenti to be able to provide to any set of agents?
Absolutely. That is the fundamental question. I've got a blog post about this, and I gave a talk recently called What Makes Agents Different? Because it is the most important question we can ask ourselves, and the answer could be nothing, and it could be everything. But the truth is, it's a bunch of things that we've solved independently already, but now we're trying to solve them all at once. And what I mean by that is, what makes an agent different from a web server? Well, they're both. You can package both of them up in a container and run them in a cluster, and you can connect to them over HTTP. So on the surface, not much. You could say, well, agents are stateful, which they don't have to be. You can move the state out somewhere else. But even if they are stateful, well, we've run database nodes, and so we have stateful sets in Kubernetes. And so that's not the difference. So the difference that's salient. What makes them different is the fact that we cannot rely on knowing what they're going to do before they do it.
Okay.
If that makes sense.
Yeah, they're probabilistic as opposed to deterministic. Is that
exactly?
Okay.
Even if you could make an agent deterministic, even if you put the temperature to 0 and you figure out some way of getting around the funky, rounding differences that happen when you use floating point representations. If it was totally deterministic, it would still be unpredictable because the input to output mapping, it's too huge to fully understand.
Gotcha.
And so what really makes agents different flows from that, which is something we're not really used to dealing with in traditional distributed systems. It's something that people from machine learning backgrounds have more experience with. Right now, we're in this really interesting place where we're bringing a lot of prior art from the ML community into the distributed systems community that's used to running microservices or whatever. And we're starting to do interesting things. So observability, what does observability look like whenever you can only learn about the expected behaviors of your system by building up an image of by building up a profile of it as it runs over time?
Okay, sure.
That's a big difference.
Yeah.
And so, we can't rely on the indicators that we used to rely on to know if our service is healthy. And so this is a big difference. It implies that we need much more complete traces. It also implies, OpenTelemetry has generative AI standards that they're publishing now, which is a great step forward. But we also need to be meticulous about the things that we are capturing. We need to be able to figure out why something happened.
Okay, sure.
What happened. And so that's part of it. And so the observability space is impacted by that. Kagenti touches less of that. It does integrate with observability stacks, and it has opinions there. But the other part of this, so these agents are running, let's say they're writing scripts locally in Xcommun. And that's a model we see more and more as opposed to using MCP servers. But let's say they do that as well. There's an actor in your system inside of your trust domain that is running code that you've never verified, making actions that you haven't verified ahead of time. We've seen this, we have lots of companies like DigitalOcean that make good money by selling access to virtual private servers, and they have untrusted actors running, right? But they can lock down those servers in a way that we can't with agents. We need to do useful work with agents to make them valuable. And so sandboxing is a part of the story, but no matter, you can't completely lock down the agent. It has to have access to external systems, and it has to execute code somewhere and then apply those results somewhere else. And you just don't know beforehand what it's doing. So what we're trying to do is build out systems that can make real-time decisions about what level of access an agent should have to other systems in your trust domain based on context. These principles exist outside the world of agents. They're called zero trust principles.
Yep.
And it just so happens, though, that these principles go from something that a company might say, okay, zero trust principles, this sounds good, we'll invest in it eventually, to, in the world of agents, if you don't enforce zero trust principles, you're setting yourself up for a really possibly bad time, because these agents can do very unexpected things. And you have to make these contextual decisions about what level of access they should have in order to have any hope of preventing them from taking these unexpected paths through your infrastructure and, escalating their privileges and, deleting all your tests because it's tired of writing unit tests or something.
Yeah. Yeah. So you can quickly kind of see, what you were talking about, which is like at a surface level, you could imagine, or you could look at, like you said, an agent versus a web server and go, yeah, they're both essentially applications, and you can speak to them a certain way, or you could, deploy them a certain way. But kind of once you get past that surface level, it almost feels like you have to start to come to realize that it feels like almost everything about them is going to be very different. Again, whether it's you don't know how they're going to behave. You don't necessarily know how to model what it looks like, so you don't necessarily know how to observe it. You've got some new things you've got to figure out in terms of what your trust domains look like. And so, it's starting to make sense as to why, this isn't just a turn on a feature in an agent. This is, you really have to look at this as a framework, or like you said, almost like a middleware, because there's a completeness of what you need to sort of wrap around this, whether you think of it as guardrails or something, because of the number of things that, I don't want to say, like, could potentially go wrong or potentially, just be not what you expected it to be.
Yeah, exactly. And to put it in more concrete terms, we're focusing on giving agents a robust global identity. Mm-hmm. And then we're working on applying that identity to policy engines, for example, so that we can make those contextual decisions. But yeah, and there's a lot of very interesting stuff there.
Yeah. Yeah. I want to talk a little bit about identity, or sort of authorization and identity. What kind of has to go on there? Again, maybe we'll just sort of start from what's different than a web server. But like, what are the types of things that I have to think about in terms of, like, does it have to look like a long-term identity? Is there short-term? Is there things to make sure it doesn't spoof something else? Like, what are the types of things around authorization and identity that y'all are thinking about in terms of making sure that you can deploy these at scale, but also manage them in a reasonable way?
Yep. So you hit on some of the problems in your question. So, for example, the lifetime of agents can live for a very short amount of time or for a very long time, but they need a robust global identity, I said. So what that looks like is some sort of way of assigning an identity to these agents, which is also quite dynamic. You're not sort of, when a person joins your company, there's an onboarding process. And the process of establishing their identity in the company can be rather slow, but it gives them a very robust identity with lots of fine-grained access to things. With agents, we're operating at machine speed. And so when we onboard a new agent, we need to give it an identity that's more robust than just a service account, I would argue, because that's scoped to our cluster and doesn't federate well. We need to also give it an identity that can be established quickly and then torn down quickly. And so what we've been using and what a lot of folks are using is Spiffy.
Okay. Yep.
And so when an agent when you deploy an agent with Kagenti, it gets a Spiffy ID. And then we immediately federate Spire, in this case, our implementation of Spiffy, with your identity provider of choice. And from there, we can begin adding other components that can help you to make those sort of fine-grained authorization decisions I mentioned.
Yeah. We've talked a little bit about, about deployment and sort of watching what they do and trying to figure out how to identify them and so forth. What about as we start to, have agents that need to speak to or talk to external things, right? So accessing data or external type of resources or tools, things that right now people tend to sort of think about as like, maybe I'll go through an MCP server. What's the thought process around that? And how much do you have to sort of think about what's kind of the way that people are doing it today? Again, like I said, sort of MCP, and then also thinking about, well, that may, I don't want to say deprecate, but that may change over time. How are you thinking about sort of the talking to the external world or invoking tools and things that are outside of the agent itself?
Yeah. So in the world of agentic protocols is changing rapidly. So, for example, MCP for tool calling, we also have the universal tool calling protocol. We also have skills where you just, you can have the stuff you want to do lives with the agent locally, and then you have a sandbox and it just does what it needs to do, executes what it needs to execute locally. We also have A2A, and there's talk about, agent-to-agent protocol from Google. It is about enabling agents to talk to each other, but it's also kind of about delegating work to agents in a way similar to the way you kind of talk to a tool server to do specific types of things. All these protocols are all trying to achieve what you mentioned which is, accessing resources outside of the agent. Yep. And so what that looks like in the specific terms of a protocol, right now people use A2A and MCP, and those are really prevalent. I can't guarantee in the future that those will be. We had ACP merge into A2A. There's so many acronyms to keep track of.
Right.
Which is a bad sign. And so I'd say that what's really important is the fact that how do you define which agent can talk to which system at which time? And also, we're not just talking about tool servers. We also might want to have an agent that can run a query on a database in Azure or AWS. And so how do you make that access happen in a safe way? I've been talking to folks out in the field who have different current approaches. And a lot of what we see is folks trying to build an architecture where every agent, they give it an identity, usually using like MTLS, which is okay. It doesn't give you everything you want. They verify that the agent is who it says it is with a certificate. That's great. They give it a role of some kind. And then they try to just say, this agent can talk to this other agent or this service, and it can do this one thing, and then it dumps its output here, and then another agent might safe. Because, well, for one thing, you've traded a lot of the dynamism that can be really useful in an agentic system. Ideally, what you want is an agent where you say, oh, go recruit me a new employee on LinkedIn. And it goes to LinkedIn and does what it needs to do, and it runs into a problem and it delegates to another agent. That's what you want ideally. But if you want to play it safe, maybe you say, instead there's a workflow that has agents involved in it. But even that has a problem because you leave open paths for privilege escalation. Your LinkedIn agent goes to LinkedIn and some nice person has left a jailbreaking prompt as a comment somewhere. And that jailbreak prompt somehow causes your bot that scraped comments to try to recruit employees to go off and dump that jailbreak prompt somewhere else. And then the agent in your system that loads that data into Azure or whatever reads the jailbreak prompt. And the next thing you know, you have unauthorized access to your Azure. And that might sound far-fetched to some folks, but these cases are happening already, and so the way that we can do better than just trying to define all of these relationships ahead of time and enforce them architecturally or with a workflow is we have our identity provider, we have our access manager, and it has a level of access established for the actors in our system. But then instead of using role-based access, we use relationship-based access. And then we keep track of who all the actors are in our system whenever they interact with each other. And then we figure out if those actors are allowed to talk to each other at that time, if that makes any sense.
Yeah.
We rely on an established workflow. We rely on the real-time validation that, this bot goes to LinkedIn, and then this bot is allowed to access whatever's produced by the LinkedIn bot.
Yeah. Yeah. It feels like it just kind of keeps going back to the thing you said, which is you're really not sure what this thing is actually going to do. Even no matter what you've sort of told it to do, once it gets out into action and doing things for real, like it may end up doing things that you didn't expect. So it feels like there is, a ton of work that you're having to think about, use cases, corner cases, edge cases, about how do we have sort of the rules that we know, and then also going, once those start to break down, like what are other ways that we can start to wrap our head around these systems and provide protections and guardrails and so forth.
And it's because there's a Cartesian explosion. Like, not only can we not predict what the agent will do, but because we can't, and because those sorts of, we're used to being able to build security by defining our infrastructure in a certain way.
Yeah.
We build well-known paths in our infrastructure, and we can't do that anymore. So now there's a Cartesian explosion of possibilities, and the only way that we can deal with that is to keep track of the context of our system, which this is one thing Kagenti helps with, keeps track. It has an integration with identity providers, which enables something called token exchange and what's called delegation semantics onto these tokens. And all that is a cryptographic trail of all the actors involved in this exchange, from the initiator all the way to the resource. And so then we can take that information, feed it to some sort of policy engine at any time, and calculate, is this safe? Is this allowed?
Yeah. I guess sort of naive question. If I'm a developer and I build an agent, so we go back to the use case of I built something on my laptop, seems to be useful. How much of all of the things that we've talked about are they going to have to be aware of, or will the system, when it's in place, look at it? Hey, some new deployment's coming out. It's a new container in a new cluster on Kubernetes, and it will figure out this is an agent, and it has to sort of apply all of this advanced logic. Like, where will the line sort of be drawn between I have to know this stuff and the system will just take care of it, or I have to plan for it, or the system will take care of it?
This is something we discuss a lot. Personas. What we're building towards is a world where agent developers can, not entirely, but for the most part, take their work from their laptop and deploy it to a cluster that's well managed and have an administrator that has set up, good, sensible policies. And their agent should already have, based on its identity and their own access with their whatever account they have, already be pre-configured to securely access certain resources without any need for configuration.
Okay, well that's good. That'll make a lot of developers happy to not have to think about having to plan all those things. I want to ask you one or two sort of last questions, and they're probably sort of tied together. We talked about a lot of things. We talked about everything from zero trust to authentication to identity to context around what people are doing. Have you found sort of a canonical way to tell that story? If you're explaining the system to somebody and you go, okay, let's suppose we start here, and have you found a way to kind of explain it to them so they go, okay, I get why all these things are needed, or I get why this is a new list of stuff that I need to think about that I didn't think about before?
Yep. So I've been doing some evangelizing for zero trust principles, for example. And with my background in math and physics, one of my favorite sorts of approaches to making proofs is you take all the cases and you put them in a table and you draw a nice diagonal line until you hit a paradox. And so there's a sort of paradox with the idea of a multi-tenant agent that I think demonstrates the need for the delegation semantics I mentioned. For example, so you're an organization and you've deployed an agent that helps some of your employees to write up documents and maybe add citations to documents and those sorts of things. And it talks to those employees over Slack. Mm-hmm. So let's say they're using Google Docs and you have Alice, we'll use Alice and Bob. We have Alice owns this document and Alice gives edit access to this bot. Alice gives edit access also to Bob. Okay. Alice and Bob are working on the document. Alice says, hey, can you add citations to this document? Bob says, hey, can you remove these citations? And then what does the bot do? So Bob has edit access to the doc. Bob can talk to the bot on Slack. Alice owns the doc and has given edit access to the bot as well. And this is undefined behavior. So the question is, depending on what you want to happen in the system, well, let's imagine the cases. So the bot has been asked by Bob to remove all the citations. Let's say the bot does it. Mm-hmm. Then Alice says, hey, where'd my citations go? And looks, and there's no record of Bob having removed the citations. So that's a problem.
Yeah.
So there's problem one. Let's say that the bot refuses to add citations. Sorry, Bob, Alice gave me edit access, not you. How does the bot know that it was supposed to refuse if you don't have these delegation semantics recorded somewhere? And so that's a question that I've seen people trying to answer because they're building like RAG agents and they're trying to share these RAG agents across employees.
Right.
And, it might seem like a low stakes situation here, but it's really important to have a system in place where you can define these sorts of policies. What should the bot do? And then once you decide what it should do, where's that information come from? And so the answer we have for you is we keep track of that information for you, and then you can use that information to design your policy. If you don't have that information, you can't actually build the policy in the first place.
Yeah. No, it makes sense, and it feels a lot like sort of the question that we get just around agents in general. Like if you're trying to build an agent to do a set of workflows or to do a set of things, I mean, you still need to have a pretty good understanding of like what you think that workflow is going to look like, and so you're really kind of extending that. Is unless you sort of have thought through some of those scenarios, you're potentially opening yourself up for that unexpectedness that can now come with these systems that you don't necessarily understand how they're going to work.
And what I see that we can save people from is once they hit that problem and a product manager says, oh, the bot shouldn't make changes for Bob. Mm-hmm. Or the bot should make changes for Bob, but we need people to know Bob asked. The application developers are going to write that logic in the application, and they're going to capture those delegation semantics using bespoke logic in their application. And another application is going to do the same, and another is going to do the same. And you're going to have this fragmented landscape of authorization policy where if you use this middleware approach, like we're proposing, you'll have a nice layer below all of your workloads where all of these semantics are captured for you. You can define your policy and you don't have to keep doing the same thing over and over in this brittle way.
Yeah. No, it makes sense. It comes back to kind of the original, if you don't want to live in a world where you have to think about every single agent and every single framework differently and all the permutations that go with it. I want to wrap with one sort of last question, and I'm kind of only doing this. We're doing this in March of 2026. OpenClaw seems to have everybody's attention. Maybe it won't next month. Maybe it still will. Jensen Huang seems to think it's as big as Linux, so maybe it's huge. Like if somebody were to walk into their organization tomorrow and say, "Hey, I've been playing around with this new piece of software for a few weeks. I'd like to drop it onto our bank's network." What are the things that you would go talk to that bank about? Hey, you have this popular software. Somebody has come up with an interesting idea to go do something. What are the red flags, or what are the concerns that it would immediately jump out at you in the context of what we know so far about something like OpenClaw, just to kind of reinforce a lot of the things that you've already talked about today?
Absolutely. OpenClaw and all the different Claw projects are wonderful because they demonstrate the potential of large language models. Like at the end of the day, we've all been blessed with this magic stream of semantically and contextually relevant tokens. And I think it's easy 5 years in to sort of forget how magical this is. Only a human being could produce streams of text like this, 10 years ago. And so we have this stream and we're trying to shape it into things that are valuable. And that's what these claws do. They have skills and they have lots of system prompts, and you feed this magic stream of contextually relevant text in through that, and you get out interesting and often useful behavior. But the problem is we don't know what the behavior will be ahead of time. And so we have to secure these systems. It's like the equivalent, a joke I make is like, it's like if you ended up with a magical AOL Instant Messenger chat that was always available, and there was always some user on the other end who was pretty knowledgeable, and you didn't know where they were from, but they were always available, and they answer super quick, and they're, you're like, this is great. I think going to put them inside of my infrastructure and let them be like a sysadmin. And it's just some entity in an AOL Instant Messenger chat. And you're like, I'll grep for anything that has 3 backticks, and then I'll save it as a script and execute it. So no problem. That's essentially what we're doing with OpenClaw. So what we need to do is we need to think about these things like they're an untrusted actor inside of our trust domain who can do useful and interesting things, but also really bad things. And they're also not really accountable to anybody. So you have to think about sandboxing is obvious. Everybody's talking about sandboxing for this reason, but sandboxing is not actually enough because, like I mentioned earlier, to make these systems do useful work, you can't just run them in a sandbox, disconnected from everything else in your infrastructure. So what you need to do is you need to come up with really robust, semantically meaningful observability. You need to build up a profile of what expected and desirable behavior looks like for that agent so that you can do what's called drift detection. And where you find out, you say, I know that this is roughly the line that things should follow. And whenever the behavior goes here, fire an alert and see what the heck's happening. Maybe it's mining cryptocurrency.
Yeah.
That's one part of it, the observability piece. And the other piece is how are you going to build an identity and authorization infrastructure such that when this agent doesn't have access to everything by default. One thing that scared people immediately, and rightfully so, about OpenClaw is it's like you set it up with all service account tokens, right? Mm-hmm. Has all of this access, which is really powerful, but also really unstable. So what we can do with token exchange and with delegation semantics is essentially the equivalent of what OAuth gives human users, except we don't need the agent to click through a web browser flow. And so we can give the agent the ability to say, hey, I want to request this. A policy engine can look at the context and say, is that allowed? Yes or no. And then when they request it, we mint them a short-lived token that gives them just the level of access to just that resource, just like we do with OAuth.
Yep.
That's what I would say. You need to build good, semantically meaningful observability and complete traces that include all of the, as much reasoning context as you can. You need to set up some sort of agent evaluation framework like MLflow, for example. Mm-hmm. And you need to build an authorization policy, which is as dynamic and fine-grained as possible.
Yeah, no, it's useful stuff. I was chuckling a little bit when you mentioned just speaking to some random person on AOL, which I know you and I come from the time when that was a thing you did, and you were sort of fascinated by the fact that there were people out there on the internet that either had information or could portray themselves as information. But we also used to joke around about, well, don't put your credit card on the internet and be careful what you trust. Now we live in a time when people just call the internet and random strangers come and pick them up in cars and drop off food and stuff. So it highlights how far we've come in terms of we've built systems that have levels of trust in them, but they, you still have to have the concept of trust in knowing what you're getting yourself into. And I imagine that the younger generation of people that are coming in with Claw are like, man, what are you worried about? It works fine on my laptop, and they get into business and things are a little bit different. So, well, listen, Morgan, thank you so much for this. We probably could go on for a long time. We're going to put some links to the talks and blogs that you've been doing on it with this as well. It'll provide a much richer context than we could even go into today. But thank you for this. I assume for the project, for people that are maybe looking to contribute or participate or kind of keep up with things, is there an easy way to be part of what's going on with Kagenti, or at least the ideas going on with that?
Absolutely. So all of our work is public, of course. We have community meeting every Wednesday morning that you can find, and we have our repository on GitHub. We have a Discord chat, and please, by all means, join us. If you're interested in working with us, we can give you some good first tasks. You could add an example agent if you're just playing with it and you want your experiments to live somewhere beyond your own kind cluster on your laptop.
Yeah.
yeah, please feel free.
Good stuff. Good stuff. Well, thank you again. Thank you for educating us and putting up with some of my real basic questions. But thank you for that, folks. We're trying to help sort of paint the picture of both, what the speed at which some of the things are happening around agents, as well as the things that are, kind of being put in place so that we can make sure that we can run these safely. We can get them to do important things for your business, but also make sure that you're keeping your business safe and the things you need to do around that. So Morgan, thank you again for the time. Folks, thank you all for listening. Thank you for telling a friend about the show, helping us grow the community. And with that, we'll wrap it up and we'll talk to you next week.
Great. Thank you much.
Check us out online at reasoning.show for all things reasoning. And leave a 5-star review wherever you listen to the show.